In this video, we are going to discuss about types of operating system, right? So first type is real time operating system. So what happens? Suppose I gave a command and I want an output from my system, right? So that output must be very immediate and there should be no time delay, right? And here time matters, right? There should no time of delay and time matters for my output, right? And this is done in real time environment, right? This is done in real time environment. And there are two types of real time operating system. One is hard hard and second is soft real time operating system. So in hard real time operating system, I want my output to be immediate as quick as possible. I don't want any type of delay. For example, missile system. And in flight automation, if there will be a little time delay, then my output will be manipulated and it will not give accurate output. Suppose I want to drop a missile here, and if there is time delay of even 5 seconds, then my missile can go here, right? It won't hit the target. So time is very critical here and there should be absolute no time delay. While in soft, a little time delay can be entertained. For example, in computer gaming or in YouTube live stream, we can afford a little time delay in which there is no critical situation might occur. There is no critical situation that can occur in computer gaming, but if here it's even little time delay, a critical situation can occur, right? Now we will discuss about distributed, right? So suppose these are my systems, these are my machines, right? And these are connected through networks, right? So in my distributed time system, I create an environment in which my machines are distributed, my system are distributed all over the world geographically, and each machine will have its own kernel, each machine will have its own disk, and each machine will have its own memory, right? And if one machine will fail, then I can give the process to another machine and I can continue my work. This was distributed operating system, right? These machines are not at one location, these are distributed, all are independent, right? And Facebook and Google uses this technology. Now we will discuss about clustered operating system, right? So in clustered operating system, what I did, I took many machines and I clustered it in one, right? I clustered it to one in such a way that that machine, that entire will act as a single machine and it will act as a what? Supercomputer, right? Because I will be having one machine acting as a work of 200 machines, right? Because I have 200 different machines but all are clustered, right? So in clustered machine, different machines are used as one cluster connected through local networks. They are connected through local networks, and if one system fails, that work will be done through another system, right? And now, yes, they will act as a single server, and yes, and The benefits are, one is availability, right? And then second is false tolerance, that I discussed earlier, that if one machine is not working, then we can work through all other machines, right? And third is scalability, right? On high scales, right? On suppose I have a power of X producing, so through a scalability I can make my power output as 2x, right? Now I will discuss about embedded operating system. Embedded operating system. So what happens? The operating systems or machines which are embedded with fixed functionality, those are known as embedded operating system, right? For example, microwave, AC, right? They work on fixed functionality. If I will say my washing machine to heat food, that is not possible because they have fixed functionality. It is encoded in their programs, in their interface, that they have to act like they are instructed, right? Now let's discuss about multi-programmed operating system and multitasking operating system. So let me erase this. Let me erase this, then we will discuss about so we will discuss about multi-programmed operating system. Multi-programmed operating system. So what happens? Right, in multi-programmed operating system, suppose I have my machine and there are P1, P2, P3, P4, right, Pn processes in my machine. And what will happen in multi-programmed operating system? Suppose I want my P1 process to be executed by CPU, right? So CPU will execute it, right? So what will happen? CPU will execute it, right? So what it will give? I have my output, right? Suppose I gave an input, I gave a command. So what will CPU do? CPU will the input will go as input output operation, right? And what will happen to CPU? It will become free, right? It will be getting its idle time, it will be resting. So we don't want CPU to be idle, to be rest, right? So we will give new process to CPU, right? And once I give a process to CPU, it will completely execute it, right? So suppose I have 10 students, right? And I have one student having 5 questions each, right? And suppose I am going to each students, and I am CPU, right? I am go to each students one by one. I will solve their 5 questions. Then I will go to second student. I will solve their 5 questions, and then I will go to 10th student. I will also solve their 5 questions. So this is how what happens in multi-programmed OS, right? There is no idle time, right? but the time taken from going from one student to the 10th will be very high. But what happens in multitask multitasking operating system? Suppose there are 10 students and each student is having 5 questions, right? Each students are having 5 questions. So first I will go to first question, I will solve their 2 questions. Then I will go to second student, I will also solve their 2 questions. And in this way I will reach to 10th student and I will solve their 2 questions. Then I will again go back to the first student. I will solve third and fourth question. And in this way I will go to second student, I will solve their third and fourth question. And this process will repeat. So this is multitasking operating system. The benefit will be what? From going from one student to the 10th student, time will be very less. So the benefit of multitasking operating system is responsiveness, right? Responsiveness is very immediate, and multi-program operating system focuses on no idle time for CPU. So what happens in multitasking OS? All processes are being contacted, are being called, right? So that responsiveness of each process will be high. It is not like this that it is completely executing only one process, then go to another and then go to another like this, right? So this was all for this video.